So we just asked to calculate 4 midpoints. So given 4 line segments, it's just the size of a quadrilateral. So midpoint of QR. Okay, so again, done this several times, this formula just sticks in our head. And at some point, you get to the point where you don't have to write down the formula, right? But until we get it in our head, just keep practicing that. So QR, the x's are 0 plus 6 over 2, and 4 plus 3 over 2. So that gives us 3 over 2 and 7 over 2. Sorry, 6 over 2. So that gives us a 3 and 3 over 2. So if you plotted the quadrilateral, you kind of see that that point makes sense as a midpoint. It's right there. Okay, I don't want to do the math over again. Again, it's the same formula applied over. The midpoint of RS. So here I'll call this A. So A is 3 and 3.5. B here will be 7, 2. 3 and negative 1/2. Negative 1.5. And finally, D would be 1 and so it's just 4 midpoints done really quick. Sorry, negative 1, yes, it's up. So if we connect these, what kind of shape do you guys kind of see?
A rhombus.
A rhombus. That's pretty good, Robert. What's a rhombus?
That's like a diamond.
It looks like a diamond. But what special characteristics did a rhombus have?
All the sides equal.
All the side lengths are equal. What else? Opposite sides are parallel. Okay, Adrian?
I think there's a slight calculation error for point A.
Is it not 3 and 3 over 2? No, it can't be over. It's 7 over 2. Sorry, I couldn't read my own handwriting. So 3 basically 3.5. Is that right, Adrian?
Yes.
Yes? Okay, thank you. Okay, so it is we connect all that, and Robert is kind of right. It looks like a rhombus. The question number 2, or sorry, to calculate the slope and length, this is what we're actually doing to verify that it's a rhombus. Okay, so we go off and calculate the slope. So again, I'm not going to do all 4 of them, but let's say if I do the slope of AB. So slope of AB is delta y over delta x, 3.5 minus 1 over 3 minus 7. So that gives me negative 2.5 over 4, negative 0.625. Thank you. Okay. So we do the slope of DC, we should find the same slope. Okay.
Isn't it 3 minus 7 plus
Why? It's supposed not supposed to be negative 2.5. It's just 2.5. It still comes out to be negative. Okay. Thank you. So we're finding that those 2 slopes are equal. And you do the slopes of dA. So delta y over delta x is equal to 1 minus 3.5 all over negative 1 minus 3. Here I get negative 2.5 over negative 4. But it's 0.625. Then we calculate the other slope of CB. We get 0.625 as well. Okay? So then you prove that the 2 opposite slopes are parallel. That's actually how you prove it's a parallelogram. So since the slope of, which was the first one I did, AB? Slope of AB is equal to the slope of DC, and slope of is equal to the slope of CB. ABCD is a parallelogram. Okay? Yes, Kate.
You know how for slope and midpoint, you both put M first? For midpoint, is it a capital M? Like
Yeah, so midpoint is a big capital M,
and then slope is
lowercase. So that extends just from grade 9 when we did slope intercept form, right? So we're just remember lowercase m is slope.
And for slope, do we use capital letters for like choosing the side lengths? Like
Well, it wasn't so much because we use the points. We use capital letters for points.
so you just put that into the.
So yeah, so here we're just saying it's a slope from A to B. Okay, so that's what that notation means. Here we get the slope from D to C.
And I do y2 minus y1.
Yeah, and then it's just taking those D and C points and just doing y2 minus y1. Okay, that's all. But what we could also do is to also calculate the lengths. So I'll just do one length formula. So I'll do DC. So length of DA actually I'll do, since the points are right there. So that's the square root of my x, -1 plus -3, squared plus 1 minus 3.5 squared. So I get the square root of -4 squared plus -2.5 squared. So that's equal to square root of 16 plus, that's 2.5 squared? 6.25. So that's the square root of 22.25. And what's the square root of 22.5?
4.17.
4.17?
4.71.
Okay.
I don't know the.
This is all sides of the same.
Yeah. Sorry? Adrian?
Exact form means like square root. Like here.
Sorry?
Does exact form mean non-decimal form?
Exact form means a radical form, yes. Okay.
I didn't attempt that.
But since we got to decimals here, and we get to fractions, it's a little bit hard, so I would accept that. So as Daniel pointed out, once you do the lengths of all the sides, which is what I got you to do, since all the sides are the same, all the sides are the same length. ABCD is actually a rhombus. So if I was to pose a question, prove that ABCD is a rhombus, we have to do multiple things. First of all, prove that the slopes are opposite, but you also have to check the side lengths. Okay? So it's a little bit of a work, but you notice it's the same question over and over again, which is why that practice is important. Right? This unit isn't hard, it's just you need to practice those concepts over and over again, those equations. Right? Any questions of this example? So really just can you do 3 things 4 times, 12 parts just to prove a shape. That's analytical geometry for you. That's right? Yeah. Okay, so here's some notes. Just we go off, sometimes you may be asked to prove shapes. Just like what we did, I gave you 4 points. You may need to ask to prove something. So we already did the first one, show a parallelogram. All right, so just to put in context. So actually the first point is the line segments So this is true of any quadrilateral that you have. You take the midpoints, you connect them all, you actually get a parallelogram. It just works out that way. No matter what quadrilateral you draw, if you connect the midpoints, you actually get a parallelogram in the middle. So the second thing is, once you're given a parallelogram, or you ask to demonstrate that a quadrilateral is a parallelogram, you just need to do one of two things. You got to do the slopes. Opposite sides have the same slopes. So you need 4 slope calculations. Or you can just do the side lengths. So 4 length calculations. Okay. So you just need to do one or the other.
Wait, one or the other?
Yeah, just to prove that it's a parallelogram.
You don't need to.
Oh, that's so true.
You just, if you have 2 opposite sides, and they opposite sides have the same slope, then by default it's a parallelogram. Same thing with the side lengths. If opposite side lengths are the same, you have to have a parallelogram. Okay? So you just do one or the other. Everybody good with this? Okay, so both 1 and 2, they only require 4 calculations, right? So we can talk about other quadrilaterals. A rectangle. What else do we need to demonstrate that a parallelogram is a rectangle? Sorry? Lengths?
The angles.
Yeah, so basically a rectangle is same as a parallelogram. But one important thing, what's special about a rectangle? Adrian?
It has 490 sides.
Yeah, it has 490-degree sides, but it has 4 90-degree angles. Okay? So what does that mean in terms of slopes? What does that mean in terms of slopes? Slopes of our sides of a rectangle. How can we tell it's a rectangle then by looking at the slopes? Say it louder, please.
Perpendicular slope.
So the perpendicular slope. So what do we know about the slopes then? Yeah, right. If one and the other is negative reciprocal, they're 90 degrees. So if I was to verify if quadrilateral is a rectangle, would I calculate the side lengths or would I calculate slopes? Why would I use slopes as opposed to lengths to confirm that it's a rectangle? Like, why would I not just calculate all the lengths and say, you know what, that's a rectangle, and then I go off and calculate the slopes? Well, it could be a parallelogram, but I need the slopes as well to confirm that they're negative reciprocals of one another. Okay? Yeah. I mean, if I could use slopes to verify it's a parallelogram to begin with, and I already have those values, I'll have to check if, well, are they negative reciprocals of one another? The 2 ones are not equal, right? Because there's going to be 2 sets. If they're negative reciprocals, we take that information we already have and just extend it to say, well, it's also a 90-degree angle. If we do side lengths, we still have to go up and calculate the slopes to confirm that's a 90 degree. So might as well just take the easier route. Okay? A rhombus. Well, we just did a rhombus. What is it that we need to verify that it's a rhombus? What what kind of calculations do we do to verify that figure? So given 4 points, defines a rhombus. Audrey? But that only tells us it's a parallelogram. That's not a special quality called a rhombus. You just need all the sides.
Wait, what about the angle?
Well, all the sides. So if we do this,
Oh, it's the same.
we have 2 opposite sides the same length, so we get four lengths, and we get 2 pairs that are the same. Then by default, it's a parallelogram. But if they're all the same length, then it's a rhombus. So all you really need in this case is just the 4 sides. You don't need to do anything with the angles. How can we validate that shape is a square defined by 4 points? Yeah, so same thing as rhombus.
And then all the angles are 90 degrees.
Right? You don't need to verify all the angles, just one angle. Because by default, if one angle is 90 degrees, they will all be 90 degrees. Okay, so how many slope calculations do we need there to verify that one angle is 90 degrees? How many slope calculations? 2, right? You need negative reciprocals, so because you compare one to another, you need 2 slope calculations. Okay, so 4 side length, 2 slopes. That's all you need. So 6 calculations, but again, it's the same thing over again. Just making sure we're accurate so that we see that it's the same side length. Okay. So a good question on the test might be, what's the classification of this quadrilateral? You have to do something like this. So first thing I would do is draw it out on the grid, and then take a good guess. Does it look like a square? Does it look like a rhombus? Okay. So any questions with this geometry in terms of shapes, quadrilaterals? What is it we need to do to verify something's a shape? No? Okay, so for homework, just 2 questions. But please go back and do the other homework. I've kept it short for a reason, so that you can go back and take some time to learn all the other stuff and practice other stuff that you might have missed.